Welcome to today's lesson. Today we will be able to interpret univariate data, and we will be able to explain how univariate data can be represented. So let's take a look at today's lesson. All right, let's take a look at today's do now. The table shows the mass in kilometers of some newborn bottlenose dolphins. Write down the modal class. So the modal class for this problem is the highest frequency, which is 19, which is the 12 less than or equal to m, which is less than 16. Let's take a look at today's thinking. What is univariate data? What are the different ways to represent univariate data? Univariate data and representations. Univariate data is data that is in one variable. We represent univariate data using box plots, frequency tables, cumulative frequency tables, histograms, and also bar charts. So here we have the first piece. It's known as a box plot. We have some frequency table here, cumulative frequency table, and this piece here is a cumulative frequency graph, which we're going to be doing. And we have seen this one here before. That's our histogram. So let's use some of the way to represent this univariate data. Let's start with box plots. The distance in meters traveled by 15 snails in a 1-minute period are recorded and shown below. We want to find the values of the quartiles. We want to find the interquartile range. We want to identify any outliers. And then we want to draw a box plot for the given data. So the first thing that we're going to be doing is making sure that our data is in order, which it is. The next thing I'm going to identify is the median. So we have 15 pieces of data here. I'm going to increase that by 1 and divide by 2. So what I'm doing here is trying to find the location of where my median is, which tells me that the 8th term is going to be my median. I'm going to count and find my 8th term. To find the quartiles, I'm going to actually start with the second quartile. In order for us to find the first and the third quartile, what we have to do is we have to look at what is in front of the median and what is in back of the median. And what we are going to identify is the median for that yellow highlighted set of data and the median for the pink highlighted piece of data. So I found that 1.1 is the first quartile and 1.4 is the third quartile. B, find the interquartile range. So to find the interquartile range, all I need to do is subtract the third quartile minus the first quartile. All right, I found the interquartile range to be 0.3. C wants us to identify any outliers. So to identify any outliers, we need to know the interquartile range, which we have. We need to use the formula of 1.5 times the interquartile range. And we are going to look for the lower outliers and upper outliers. I found my low outlier and my high outlier. If I have within my data a value that is less than 0.65, that is considered a lower outlier. If I have in my data a value that is greater than 1.85, then I have an upper or higher outlier. And in this case, we only have one outlier. The last part, we want to draw a box plot for the given data. So to draw a box plot, we need 5 pieces of information. We are going to need the min value, minimum value, the maximum value, the quartiles, first quartile, second, and third, and we could put all of that together to represent it using a box plot. So the only 2 things I still need are my min, which is that 0.5, and my max, which is 1.5. Now I am going to use the given data. For part D, they didn't tell me to remove that outlier, so I'm using the given data to represent and draw my box plot. So I need my min. I'm going to do a little line for my min. My min value is 0.5. And then my first quartile is 1.5. There's a distance between them. So I'm going to extend this and make this my Q1. My Q2, my second quartile, does have a distance of 0.2. So that I am not going to make too long. I'm going to create my box. And we have the third quartile to be 0.4, which is pretty close to that second quartile. Just so it's not too sloppy, I'm going to put that on the top. There's my third quartile. And we have our max of 1.5. So every little tick mark that I did is my min, my quartiles, my max. So here's my min, my first quartile, my second quartile, my third quartile, and my max. I connect my first, second, and third quartile by creating this box, and I create the whiskers by expanding from that box to the min, from that box to the max, or from the quartiles, the lowest quartile and the upper quartile. And this would be me representing my data. I am going to include a little bit of stuff because I wasn't given a grid. So I'm just going to identify my min, my quartile 1, quartile 2, quartile 3, and my max. All right, let's look at example 2. Frequency tables and their graphs. So the frequency table shows the weight in kilograms of some cats. Complete the cumulative frequency table. So here we have seen a frequency table in the past. They filled it up for me and they want me to expand this and create the cumulative frequency piece. So how do we do that? We start with the first frequency of 8 and we start adding. So 8 plus 10 gives me my next cumulative frequency. 18 plus 21 will give us our next cumulative frequency. 31 plus 19 will give us our next, and we keep adding in a diagonal. So we have a total of 80. 80 cats have been weighed for this specific problem. Part B wants us to draw a cumulative frequency graph for this given information. Here's my graph. I have my X being my weight in kilograms, my Y being my cumulative frequency. So what we are going to do is, let me focus back on the table. We are going to plot these values at my upper end. 1 is being included, 2 is being included, 3 is being included, and so forth. So I could create my cumulative frequency that way. So we're going to start with 1. 1 is 8, And normally when we do these cumulative frequencies, we'll mark a little X. So at 1, we went up to 8. At 2, we're going up to 18, a little X. At 3, we're going up to 39. 4, we're going up to 58. So I'm just going to continue marking my little X's. Okay, so there's all my X's. When we connect these, what we want to try to do is connect them as a curve. So I'm going to start at the upper. I'm going to be as neat as I can with this. I'm going to include one more point. If we had 0 cats, that means that they were going to weigh 0 kilograms. So I'm going to include an extra 0 piece. So there's as best as I can do it. Sometimes what people do is they make each section linear. So instead of making it curvy, as I try to do my best on, they make it more linear looking. Now we are done with that piece. We're done with B. We want to identify the quartiles. So the first thing you're going to do is you're going to look at your cumulative frequency. The highest piece of information I have is that 80, which means that up to that point, we're talking about 100% of your data has been gathered, right? 80 cats have been weighed. I'm going to do the same thing. I'm going to look at the lowest piece of data. 0 cats, 0 weight. So that's 0% of my data. If my highest piece of data is at 80, what would be right in the middle? This would be 50% of my data here. My 25% of my data, which is the first quartile, would be found by looking at 50, which is 40, my cumulative frequency, and taking half of that, which would give us a 20. And to get the 75th percentile, or the 75th percent of the data that you have, I would look at the 50 mark, which is 40, 80, and what's in between. Okay, so I slowly am trying to split my data so I can find these quartiles. So in order for me to find the first quartile, that is 25% of my data. So what am I looking at? Let me see if I can highlight this. I'm looking at this piece, only that piece. So 25% of my data intersects at this location, which is roughly 2.1 kilograms. 50% of my data, where does that lie? So let me do the same thing. Let me highlight this. So looking at my graph, again, not so accurate, it looks like the graph intersects somewhere here. So roughly at 3. The next quartile I am looking at is the third quartile, which would be the 75th percentile. Okay, so looking at this, it looks like we are located roughly at 4.1. Part D is asking us for the interquartile range. So I'm going to take Q3 minus Q1. We get an interquartile range of 2. And that is all.